Okay, so now we move on into braided channels, which is our third type of channel. So we've gone over straight channels, meandering channels, and now we have braided channels. So braided channels tend to have or pretty steep gradients, and they carry a lot of sediment. They're the type of channels that carries the most amount of sediment. So a braided stream usually forms at the base of mountains. So usually a stream goes from being mountainous, being a straight channel, into being a braided channel once it goes from the foothills into the valley for the most part. So these streams, based on that fact that I just told you about, tend to be seasonal as well. So they usually happen, or not necessarily seasonal, but they are stronger during the highest precipitation, and they are there during fall and winter, but not in the greatest amount. So they have the greatest amount of discharge and of sediment load during the highest precipitation time of the year, so during spring and early summer. So you see two examples here. They're called braided streams because they have many channels that they take, all leading to the same overall direction, but they have many different channels that kind of intertwine, leaving these bars in between. So these bars are going to be basically deposits that have been deposited by that same channel, or that same stream, I should say, in different years. So let's take this one, for example. This specific bar was deposits, or is made out of deposits that were deposited by this arm when this arm used to be running through here. Then, because it deposited so many sediments, it couldn't hop over it, so it started making a different route, and now it's going around that bar. So each of these bars within the braided channel kind of works the same way. But again, all the channels are going to intertwine and change paths, on a fairly regular basis. In order to differentiate the four types of channels that I have in here, or the four pictures, I should say, of channels that I have in here, between the types, I would find two meandering streams and two braided streams. So think about it for a second. Alright, so you should have been able to see that the ones on the left are both going to be meandering streams, and the ones on the right are both going to be braided streams. So within the braided streams, you see all these bars of deposits that have been left by other channels within that stream in previous years. And then on the meandering streams, for example, you see a few oxbow lakes. So there's one over here. There seems to be one over here. It's hard to tell. But you see that in the meandering stream, for the most part, there's only the one channel, and it's taking its time flowing through its floodplain. And then in the braided channel, although it is also flowing through the floodplain, there are many channels that are kind of intertwined, and they have a lot of deposits being left in between them. Okay, so what is going overall to cause a stream to vary? And we have talked about this, but I just kind of want to summarize it. So this graph is actually pretty great. If you want to, pause this video and look at it a little bit more closely, you definitely can. But the gradient is going to be one of the bigger things that determines whether a stream is going to be straight, meandering, or braided. Also the discharge, so the amount of water that is coming through the stream at a particular point, is going to change whether it's going to be, again, straight, meandering, or braided. The sediment load and the sediment size are going to have a big effect on that as well. So you're seeing down here, for example, that the braided channels are very likely to have a lot of sediment, so the sediment load is high, and those sediments tend to also be pretty large, so they tend to be kind of sands and perhaps even gravels and cobbles. On the other hand, for example, the meandering streams tend to have a fairly medium kind of load, So you're seeing here a meandering stream. The load itself is going to be medium, and the size of the sediment is also going to be medium to small. So they're going to be kind of clay, silt, and maybe sand-sized particles. So that's going to very greatly determine whether you're going to have a meandering or a braided channel for the most part. The gradient is going to be very impacting in terms of whether it's going to be straight or not. Another variable that also makes a stream be of different types is going to be vegetation. So if there's more vegetation tends to pretty much confine the channels a little bit better. So it tends to build greater sediments that confine them. So if you were to have a lot of vegetation on the sides of these meandering channels, it is a lot harder for the channel to erode through that specific part. Whether if there is no vegetation on the floodplain of that channel, it's going to be easier for the meandering channel to maybe take different courses. And so it might become a little bit more like an in-between meandering and braided channel, something like this, if the vegetation is lower. So there are many factors that come into play when determining whether a stream is going to be straight, meandering, or braided. But as you're going along on your different trips and adventures, I encourage you to try to determine what kind of channel you're looking at. And again, these channels may vary as you drive through them. It may become straight towards braided, or it can go from being braided towards meandering, or all sorts of combinations. So the channel pattern itself, so the channel type, is going to determine how big a floodplain you have and how it's going to shape. So a meandering or braided channels usually are the ones where you're going to have some sort of floodplain formation due to them. So say this is a meandering channel example, but say you had a braided channel that was very or carried a lot of water and sediment during springtime. During those times where it carries a lot of water and sediment, it would be constructing a larger area where the water flows. And then during times where it doesn't carry a lot of water or sediment, it's going to be a much smaller channel, and hence the floodplain is going to be that area where the channel is greatest or carries the most water and sediment during the year. In this case of the meandering channel, I have told you before that the floodplain is very commonly created by the meandering of the channel itself. So the channel is going to take its time, perhaps do a different course every time. Maybe now it's doing this instead. And so while it travels through this fairly low gradient valley, it's creating a different path for the channel itself. And with that different path, it's also carving a floodplain itself and depositing sediments that are characteristic of a floodplain and are easy to erode through as well once the channel of the path, or the path of the channel changes. So again, a floodplain is going to be whenever you have the flooding over the confinement of the channel. So if there is too much discharge that it can no longer, the amount of water just cannot fit into that confinement of the channel, so that no longer water can fit through here, it's going to overflow into certain parts of the floodplain. So if this was all the same elevation, all the water would appear throughout the whole floodplain. But because most likely this is going to be slightly lower elevation, these brown areas, for example, are going to be slightly lower elevations than this kind of green bushes areas, then these brown areas are going to get flooded first. And then if even more water is traveling through the channel, then perhaps all this kind of green bushy area is also going to get flooded. So overall, that is the floodplain. And depending on the amount of water on a particular flood, you're going to get greater amounts of that, or greater areas of that floodplain flooded, or lesser areas of that floodplain flooded. So let's get a little bit more into flooding, which is actually the topic that we are supposed to be talking about. So flooding is otherwise known as the overbank flow. So the bank is going to be those sides confining the stream. So it's going to be flow that happens over those banks. Okay, so this flooding is going to be a function of three different things. The first thing is the amount and distribution of precipitation into that drainage basin. So remember that drainage basin is going to be the area that any water that falls within that area is eventually going to coalesce into the same stream. So if, for example, you have a lot of precipitation, a lot of, let's call it snow for that matter, that falls within that drainage basin, and once springtime comes and it becomes runoff, it becomes water that flows through on top of the surface, and it incorporates itself into the river. If the amount of snow that we got was too high, then we're going to get some flooding. Another function of the flooding is going to be the rate of precipitation infiltration into the earth. So remember that infiltration, which is that the water actually goes into the ground to become groundwater, is going to be one of the two things that might happen to the precipitation. It can infiltrate or it can become runoff. So if the amount of water that precipitates is greatly becoming infiltrated, then not much surface water is going to flow. However, if the greatest amount of water that is being precipitated becomes runoff, not so much is infiltrated into the ground. So the things that may determine whether water infiltrates or becomes runoff are going to be the soil type, are going to be the vegetation, are going to be the gradient. All those things are factors that influence that. But as an example, let's have two different types of material that the water falls on top of. So let's say that precipitation as rain is falling down into two different materials. The first one is going to be clay size or clay particles, and then the other one is going to be sand particles. So water does not infiltrate easily through clay. Clay tends to be very permeable, meaning water is not going to want to go through it. So the water that goes through the clay is going to instantly become runoff. It's not going to infiltrate. However, in the other case where we have sand, sand tends to be a little bit coarser grained, and it has a lot of spaces in between the grains that it has. And so water is going to more easily infiltrate those empty spaces between the grains. So water that falls on sand is a lot more likely to infiltrate that water than that flows on top of clay. So that's another big factor for flooding, the rate of precipitation infiltration into the earth. Another and last function that flooding has is going to be how quickly that surface runoff reaches the river. So that is going to be mainly dependent on vegetation and on gradient. So if the gradient is very high, is very steep, then it is very likely that the runoff is going to reach the river quickly. If the gradient is very low, it's very likely that it will reach it slowly. Another example is if there's a lot of vegetation, it may make the path of the water a little bit harder, and so it's going to take a lot longer for the water to reach the river than if there was no vegetation at all. So let's have this scenario where I want to see when would be the easiest flooding events based on those three different conditions. So clearly I would have easier flooding if I had no vegetation, high precipitation, a clay-sized or clay particle bed, and I had a lot of precipitation and widespread within my drainage basin, and it was springtime. So that combination of factors within those three different functions would give me the best option for flooding.